All right, let's get right into it. Today, we're talking about how two of the biggest technologies out there, AI and blockchain, are coming together to solve a massive problem in modern DevOps. We're going to cut through all the buzzwords and see how they're building a new foundation for something called intelligent trust.
So let's kick things off with the one question that really frames this whole conversation. As our DevOps pipelines get faster, more complex, and more automated, are we accidentally giving up trust just to gain more speed? How much can we really truly trust what's happening inside them?
And believe me, this isn't just some theoretical what-if scenario. The risks are incredibly real. The log files we count on for audits? Yeah, those can be changed. Critical build data can be overwritten, either by mistake or, even worse, on purpose. For any company, but especially if you're in a regulated industry like finance or healthcare, this is a ticking time bomb. So here's our game plan. First, we'll dig into the DevOps trust problem itself. Then, we'll look at how blockchain can build a solid foundation of trust. After that, we'll see how AI brings the intelligence into the picture. And finally, we'll mash them all together to see what this future of intelligent trust really looks like.
Okay, let's dive into part one, the DevOps trust problem. The funny thing is, the very things that make DevOps so amazing, that incredible speed, that deep automation, are the same things that can create a kind of black box, making it super hard to actually prove what's going on under the hood.
So now for part two, let's talk about our first major tool for fixing this, blockchain. And let's be super clear here. Forget about cryptocurrency for a minute. We are not talking about Bitcoin. We're talking about the core technology itself, a powerful tool for creating a completely unchangeable, tamper-proof record of every single thing that happens in your pipeline. So in our world, in the DevOps context, blockchain is really about three key things. First, immutability. That just means once a record is written, it can't be changed, ever. Second, traceability. You can follow the breadcrumbs of every single step, all the way from a code commit to its final deployment. And when you put those two together, you get verifiable trust baked into every single build, every deploy, every change you make. So how does this actually work? Well, it's a pretty straightforward process. First, something happens in your pipeline. A build kicks off, a test runs, something gets deployed. Then that event gets recorded as a unique, verifiable transaction. Next, it's cryptographically linked and added to the chain. And here's the magic part. Once it's on that chain, that history is set in stone. It cannot be altered, period. This brings us to an area where trust isn't just a nice-to-have, it's absolutely essential, the software supply chain. The SolarWinds hack was a brutal wake-up call for the entire industry, and this quote just nails it. An attack on one tiny dependency can bring the whole house down. So here's how blockchain directly tackles that massive problem. Every single component, from a tiny library to a huge container image, gets digitally signed and its history is tracked on the chain. This creates that bulletproof record you can check your builds against. This means no hidden changes, no compromised parts slipping through the cracks. What you built is exactly what you deploy. No surprises. Now, this idea of embedding trust leads to something even more powerful. It makes you ask the question, what if you could trust code itself to enforce your compliance rules automatically? That's exactly where things like smart contracts come in. They basically turn your governance rules into code that is self-enforcing, perfectly auditable, and totally transparent. Okay, so we've laid our foundation of trust with blockchain. Now for part three, let's add the engine, the intelligence, and that's AI. This is where we make the leap from just having scripted automation to building systems that are truly adaptive and can act on their own. And you really have to understand what a fundamental shift this is. Your traditional automation is great, don't get me wrong, but it's basically just following a recipe. It does what you tell it to do. It's totally human-driven. Agentic AI is different. It's like a master chef. It understands the why, the intent, and it can adapt to the situation on the fly. The system itself becomes the driver. So what does this actually look like? Well, picture this, a system that doesn't just send you an alert when something's wrong. Instead, it detects a performance problem in real time. It immediately runs its own diagnostics across all the data, logs, metrics, you name it. It figures out the root cause, and then it triggers the right fix, like a rollback or a patch, all by itself. That's what we mean by autonomous reliability. And it's not just these advanced agents. Generative AI is already helping out all over the place, from whipping up infrastructure as code, to writing release notes, to suggesting ways to optimize our code. But look at that last slice. Human oversight. This is so important. This isn't about replacing people. It's a partnership. The AI handles the heavy lifting, while humans guide the overall strategy. All this intelligence is completely changing the game for observability. I mean, we started out just being reactive, waiting for something to break and then fixing it. Then we got better. We became proactive, interpreting data to find issues. But now, with AI, we're at the final stage, predictive DevOps. Our systems can actually anticipate failures before they even happen. This really just sums up the entire shift perfectly. We are moving from a reactive mindset of asking, okay, what just broke, to a proactive, resilient one where our systems are smart enough to tell us, hey, here's what's about to go wrong. It's a complete game changer for how we think about reliability. And that brings us to our final section, the grand finale, the future of intelligent trust. This is where we put it all together. We're combining the incredible adaptive intelligence of AI with the rock-solid, verifiable integrity of blockchain. And this is where you see the real magic, the synergy. Think about it. For decisions, AI brings the intelligence and autonomy, but blockchain makes those decisions verifiable. The result? Accountable automation. For governance, AI can predictively enforce the rules that blockchain makes permanent and unchangeable. And for our pipelines, AI makes them self-healing, while blockchain makes them tamper-proof. Together, they create a CI/CD process that is both autonomous and genuinely trustworthy. Look, if you remember just one thing from all of this, let it be this simple but powerful idea. AI brings the speed, the smarts, the autonomy. Blockchain brings the proof, the integrity, the trust. You really do need both to make it work. And that's really the end goal here. We're not talking about two separate technologies just bolted together. We're talking about creating a single, unified ecosystem, one that's built on these two core pillars, autonomy and integrity. An ecosystem where speed and trust are no longer a trade-off you have to make. So, we'll leave you with this final thought to chew on. As we move from simple automation to true autonomy, where our systems are making more and more decisions for themselves, what becomes more important, speed or trust? The real answer is probably that you just can't have one without the other. Thanks for watching.